kids. Well, today we're going to be getting into the effects of changing dimensions. Okay. Yesterday we learned about the ratios and how they change between surface area and volume and how that relates to the ratio. But today we're going to take a look at the effects of it. And yes, it's going to be word problems. I know, I can just hear your groans out there right now. Going to be diving into word problems. So sit back and enjoy. Okay, well, let's get busy with the effects of changing dimensions. Okay, if the dimensions of a solid are multiplied by a scale factor of A is just going to be a variable, then the surface area is going to be A squared times the original surface area. Okay, if it's the volume you're looking for, it's going to be A cubed times the original volume. Okay, so let's first of all take a look at surface area examples, which we're going to be dealing with the A squared. Okay, number one here, if the dimensions of a figure are doubled, how many times larger will the surface area be? Okay, as with any word problem, you want to figure out your parameters of what's in the word problem. Okay, you are looking for how many times larger will the surface area be. Okay, so we're dealing with surface area. You have to identify that, and the dimensions of this figure are doubled. Okay, so the doubled will be 2-to-1 ratio. Okay, and of course we know that a 2-to-1 ratio is also equal to 2. So we're looking for the surface area, so you're going to use the A squared, and the A is the ratio. The ratio is 2 here, so 2 squared is going to equal 4. So you know that this new size is going to be 4 times larger than the original one. Okay, now let's move on to number 3 here. All right, the surface area of a figure is 736 inches squared. If the dimensions are multiplied by a factor of 1 to 4, okay, so it's 1/4, what will be the surface area of the new figure? Okay, so we know what the ratio is, so you take that ratio, put it with that A squared, okay, you square it, and so when you got a fraction like this, when you're squaring, you put that to each one of them. Put it to the top. 1 squared is going to be 1, and then 4 squared is going to be 16. Okay, so you take that 16 and you take the surface area of what you are given and then apply that, multiply it to that number, 736 times 1/16. When you multiply that out, basically what you're going to be doing is you're going to be dividing that 16 into this 736. You end up with 46 inches squared. So obviously this other one's smaller. Okay, if this ratio is bigger, it is a whole number, it's not a fraction, then you know that the new one's going to be bigger than this original. But if it's a fraction like this, then you know that the number is going to end up smaller because it's just a portion of it. Okay, let's take a look at volume examples here. And now we're going to be dealing with A cubed. Okay, number 5 here. If the dimensions of a figure are multiplied by 4, how many times larger will the volume be? Okay, so now the ratio is 4. Okay, so that's going to be a 4-to-1, which is going to be equal 4. Now we're dealing with the volume examples because we're dealing with volume here. See the volume? We're going to cube it. So 4 cubed equals 64. Just punch that into your calculator and you'll come up with 64. So the new figure is going to be 64 times larger than the original. Okay, now let's take a look at let's take a look at this one over here, number 6. Okay, the volume of a figure is 110.5 feet cubed. If the dimensions are doubled, what will be the volume of the new figure? Okay, so we're looking at doubled. So that's going to be 2 to 1, which is going to be a 2. And of course, we're dealing with volume, so we're cubing it. 2 cubed is going to equal 8. So you take that original volume figure, multiply it by 8, and you come up with 884 feet cubed. Okay? Pretty simple. This one was a simple one. Now let's take a look at this one down here. Okay, let's do number 8. 8's going to be a fun one here. Okay. Number 8. We have a solid A is similar to solid B. Okay, we got two solids, and they are similar. If the volume of solid A is 21 inches cubed, and the volume of solid B is 4,536 inches cubed, how many times larger is solid A than solid B? So we don't have a ratio in here, do we? We don't have a ratio, but we have the volume of both shapes, both solids, okay? So we can create a ratio. So we put 4,536 up top over 21. When you divide that 21 into that, you come up with 216, okay? That is the ratio. Now what do you do with the ratio? You cube it. You put that to the third power in it, okay? So you take that 261. Now see, we're going backwards this time, okay? So what we need to do is we need to square root to the power of 3. Put that little 3 up there. Now if you notice on the calculator, you're going to have the square root with a little x up here, okay? So what you need to do is you need to put that x into the calculator, okay? Now unfortunately, a couple calculators do handle it a little differently, okay? That's why I do have this answer here so you can experiment on your calculator, whether you put the 3 first, then hit that button, and then punch 216, then hit equal. You should come up with 6, okay? There are a few calculators where you put this number first, 216, hit that square root button with the little x up here, and then hit the 3, then hit equal, okay? Just experiment with that, whatever calculator you got, all right? But you've worked this out. The square root of the third power is going to be equal 6. So you know that this one is going to be 6 times smaller, okay, because you're reducing in size from the B to the A. It's going to be 6 times smaller. So just as for the sake of arguments, if the bigger one was 60 inches on one length, then the new one would be, it'd be 6 times smaller, would only be 10 inches in length. Okay, just as an example. I don't know, it doesn't give you the dimensions on these ones, but just saying. Okay, so that's how that works. You know that's going to be 6 times smaller. Okay. All right, then I'll have in the homework. I'll have a few options of a few things to work on in homework, and just if you got any questions, just text me either on Schoology or on the actual work, or message me on Schoology, and I'll get back to you as soon as I can. All right, you have a good day. Bye bye.